Interesting. Goes with. All right, all right, all right. Hello, everybody. How are you doing? Well, let's welcome to CNCF London. We will be starting in a second. That's like always. Schedule is classical. Schedule is the same. At 7 o'clock, we're starting. After that, we have our speaker. We'll be talking about the permissions in cloud native products, what I believe it is very important. Then we'll be talking about the logs. So another thing so good to have. And stateful functions. My name is Hubert. I will be your host today. This is CNCF London. If you watch us on YouTube, don't forget to give a like, subscribe to not miss anyone, and hit the bell icon so you will be always notified. So let's just jump into it. Who we are CNCF London. We are strong, open, diverse developer community dedicated for the cloud native platform and technologies based in London. But right now, everything is virtual. So we are meeting here in the internet, when definitely a lot of CNCF products definitely helps to make word going. My name is Hubert. I am temporary replacement for Cheryl. Cheryl, if you are first time here, she's the main person who is the face and basically the face and the body of the CNCF London. She unfortunately can't join us today, so I will be her replacement. You can find me on Twitter at Hugh. This is my Twitter handle. I know I couldn't figure out anything but better. So what's the agenda for today? As I said, permissions in your cloud native products, or from Authorizon. We'll be talking about this. I am really excited to hear it. Bjorn from Humio will join us for the talking about the logs, something what is not many, when the application is designed, sometimes is missed, and boy, this is necessary. So hopefully Bjorn will help us to show up how powerful logs they are. And stateful functions from Seth on Ververica, and he will be talking about the stateful functions, something what I'm not very familiar with. So hopefully hearing more. But so let me so all people that are watching, I would like you to join this link. You can join from the mobile. We'll ask you a few questions about you. Our speakers have a lot of questions, so they will understand better audience. So let's go. Please tell us if it's first time to see here under CNCF Cloud Native London. So I am curious how many people will join us. Ooh, big no. Hopefully, usually we have 80% of the recurring people. And today is a different day. This is a brand new day for for CNCF London. There is a lot of people where they never attend to CNCF London. Welcome in this case. I'm glad that you decided to join us and see. Let's give another minute. So maybe someone who is returning will be voting as well. I'm surprised. If someone, hey, there is someone who is returning. That's saved. So you should see on top of the screen there is a link. if you missed from previous one slide, this is the link where which you can join us. But wow, we have a very strong node this time. Welcome, welcome. I'm glad that you're joining us today. Awesome. Oh, still going? Is still going? Oh, okay. Let's give one more minute. And let's see how this will. Is that stable? Is it stable? Can we call it stable? I think we can call it stable. All right. So give us a second. All right. Here's the map. And if you be some kind, let us know from where you are, where you join us today. This is a map, and you click on the country or location where you are, and tell us where you're joining us from. If we have such a strong new joiners, I'm happy to hear from where you are. All right, we have England. We have do we have some strong UK representation for now? If someone make a mistake and accidentally drop in the middle of the ocean, yes, there is a chance to correct yourself. Do we have more pins? Anybody else? Yes or no? Yes or no? Or we can move forward. If you would like to join us, there is a link on top of the page. But I think that's stable. Let's move forward. So, what's your job title? What is this? Which of these two is the best? Describe what you're currently doing. And if you select others, please leave the comment on YouTube or on the Twitch. What's your order? I would like to hear. So we have our architect, engineering manager. Okay, that's strong. Order. Oh, exciting. Let's give a few, maybe one more minute. Maybe someone will like to share what's the job title. Oh, we have a very, very strong, diverse, and there's more order. Oh, this is interesting. Very interesting. Application developer. Oh, awesome. Welcome everybody. I'm happy that everybody can join us. Everybody can listen to. It's really nice to have you all of you there. All righty. I think it's stable. It's stable. It looks it's stable. All right. Let's move on to. And now questions from our speakers. So who is using OPA, OPA, and Zanzibar? So there is the question from all. Or if you be so kind and let us know what you're expecting from it, what the answers you're looking for.
Let's see what people answer first. I don't want to kind of poison the well before people answer.
Okay, and for now, we have a very, very stable. I love that we are using old school monolith framework. It's just like.
I actually expected that to be a significant percentage. Maybe we build permissions on our own, also as a kind of a second lead, and maybe using OPA after that.
Oh, you see, we have a very, very interesting spread. So, what do you think about that?
I think it depends on the sample size.
Okay, yes, that's probably that's true. All right, I think it's stable, so we can move on to the next question. And this is the next question from Bjorn. Are you getting relevant insights from logs today? Yes. No. I lack understanding. No, because I don't have a log aggregation. No, we have a log aggregation solution, but we could do more with it. And like always, logs for our old school. I see that we have a very strong old school representation. So Bjorn, let us know what you're expecting.
I'm sort of expecting people to either be saying logs are old school, or saying, well, we're getting some insights, but yeah, we could possibly get a lot more if we spent the time.
Oh, perfect. All right. So we have a 50-50, I believe. Good question. So will you bring a little bit of information what you can do more with the logs? Because the answer what is right now leading, it is what we can do more. So will you give us what the Humio can help us with that?
I poisoned the well as well.
All righty. Is there anything else? Someone else? Let's give her few more seconds. Is it stable? Oh, 50%. So we have a split, 50-50. All righty. So it looks like I'm glad that at least no one choose the option that not even what they can do with the logs. That's that brings a little bit positive in their hearts. And move forward to the last question. And last question from Seth. How do you manage stateful services? Database, stateful sets, etcdd, or older? And I believe, Seth, can you let us know what can be older then?
I don't even know, but people always find creative ways to get things into production. So
yes, I agree. I saw even the Excel spreadsheet as a something stateful.
Hey, there you go.
If you choose older, please let us know. Leave the comments down below, or choose the chat on the Twitch chat on YouTube. We are open. Please let us know, because this is fascinating. But database is winning. Are you surprised? Stateful sets. Oh my God, I have a stateful sets. So what did you expect it? Because
I was thinking about this. I think most people are right, and they go grab a Postgres database, or they go grab something similar. But there's all sorts of tools out there, and so it's just interesting to see what people are using.
Oh, perfect. All righty. But I believe it's stable. I think it's stable. So I think we can move to the next slide, which is a big shout out to our sponsors, who they are helping to make this meeting going. And don't get me wrong, this is very important, because thanks to them, this is happening. So I think we start a little bit different this time, and we start with Zan from Circle CI. Can you give us a shout out?
Hi everyone, Zan here. I'm a developer advocate at Circle CI. It's great to be here, great to be supporting this meetup. So Circle CI, we're the leading CI/CD platform out there, basically helping teams all over the world build and ship and manage change in their applications, software systems, whatever they're building, how they're building with, and so on. We've got a couple of really cool news. Basically, if if you've seen our features, like some of them used to be enterprise only, for example, Docker layer caching, private orbs, and so on, we just reject our pricing plans. So they are all now available in the free tier. So you can actually play around with them, build whatever you want. And yeah, if you got any questions, reach out to me. I'm at zmarkin on Twitter, or just check us out, of course, circleci.com.
Shout out to CircleCI. That's amazing. I would like to say this is big. Don't get me. I'm really excited, because this sounds like a really good, compelling solution for all the DevOps tools. And now when you say that everything, it's the tiers are a little bit more straightforward, and I can test it. Fantastic. Thank you very much, Zan, for that shout out. And because Humio, and I believe Bjorn, because it's today instead of Laura, he will give us a nice shout out. Please, Bjorn.
I'll try. So I don't want to steal all my thunder, but
go for it.
was acquired half a year ago now by CrowdStrike. And well, Humio is a time series log management solution. We have a free tier now as well, which I'll be telling more about. And with that free tier, well, you can do event analysis, and the free tier is a SaaS version, but Humio is also available as a self-hosted version.
Oh, that's spicy and interesting. I'm looking forward to hear that. Palo Alto, unfortunately, David couldn't join us, but Palo Alto is a company where doing a lot of security, and we are happy that they sponsor us. And NetApp, I have a shout from Kirk from NetApp. NetApp unlocks the best of the cloud, so you can put your data to work and in the applications that run your business. It's called Building Data Fabric, and you are in the good company. So shout out to the NetApp, shout out to Kirk, and unfortunately couldn't join us today, but thank you very much for all of the sponsors, what they make the CNC of London going. That said, I think I will stop sharing my screen and all. I think it's time for you, if you be so kind, and start sharing your screen. And I think we are good to go for you.
Awesome. Thank you very much. It's a pleasure to be here. My name is Weis. I'm an Intelligence Core alumni coming to you directly from Tel Aviv, Israel. I was also a VP of R&D in a cybersecurity company, and most recently I co-founded developer tools companies. One is Rookout, and more recently Authorizon, which deals with building full stack authorizations for your products. Naturally, I'm going to talk about authorization and permissions, and specifically about them in your cloud, in how you're building them into the products that you want to deliver in your cloud native solutions that you're tailoring for your end customers. So first of all, authorization is hard. It has always been hard, but it's getting harder as things are becoming more complex. Back in the day, everyone, when you speak to a developer, they will always say, oh, I've built authorization or access control for my products tens of thousands of times. It used to be very simple. You could use something like, if you're in Python, you could take like Django, or in Java, you could take Spring Framework, and there would come some built-in administration and access control. But those are no longer applicable in the cloud native space, as your application kind of explodes into microservices and becomes more distributed. You end up replicating a lot of the components there. But still, everyone starts with, I'll have admins and not. And from that point, it's actually really hard to see where the game is moving forward. So before we kind of look in a kind of more holistic sense about the problem, let's think about the different elements that exist there that actually make it more complicated. So I already kind of touched on infrastructure. Applications today, as opposed to before, are not monoliths, they're microservices, and they're highly distributed. They might also have devices or instances that are deployed at the edge, and we need to control access to those as well, or how they tailor access to them. Third-party services. When we're building applications today, it's no longer just our code or some open source code we bake in. We're actually working with a lot of third-party services. Think about how you do billing today with something like Stripe, how you do authentication with something like Auth0, and how you do your databases and your analytics, et cetera, et cetera, et cetera. And you need to gate access to those elements in the applications just as much as you have to your own microservices. So that's already complex, and again, becoming constantly more complex. The other part is the policies. The way we enforce permissions ourselves is also getting very complicated. We used to just be able to do simple RBAC, but now with applications becoming more dynamic, more distributed, we need more complex models. Where our user is connecting from? What part of the department do they belong to? What time are they connecting? Are all elements that we need to start baking into our authorization. So as I said before, everyone starts with admin or not admin, but quickly that can spin out of control, and you need a completely different policy, a completely different set of permissions or model to work with that. And because of those distributed data sources that we have, third party that we also have multiple data sources. Let's say we want to enable a policy like this. Only users that have paid for a feature should be able to use it. We need to sync with a distributed remote data source. We need to sync with the service, something like Stripe or Chargeify, where we have that information. And the rules themselves are obviously getting more complex. And lastly, the demands of the organization itself. Security and compliance are also becoming more complicated. Security is on the rise. This meetup is sponsored by Palo Alto, so that's should be kind of clear. But compliance is also increasing. The friction around privacy, when you have things like GDPR and CCPA, now you're not only managing who should access the data, but also how are you propagating the data between the different services. So that's another critical aspect of access control that you need to bake into your products. So I think it's easy to say that this is hard, and it's, again, becoming harder. So what are we supposed to do about this? So the main thing that we can take here is we can't stick to the ways we worked before. We need a new way of thinking. We can no longer go and build authorization as an afterthought. It's not just like, oh, I'll have an admin and maybe another role. It's going to change dynamically. I'm going to face more compliance, more security demands, more demands from my customers. I'll need more complex policies. And if I don't plan for that in advance, when the problem actually arrives, when the shit hits the fan, it's going to be painful. So we need to plan for this in advance. In addition, it's continuous. Authorization is not something that we just solve once and we're done. It's evolving, it's changing as our product is evolving. And in the end of the day, we need to realize that this is critical for the end experiences that we're delivering to our customers. How people connect to our product is essentially the doorway to our product. And if the entrance is hard, we'll end up losing users. And lastly, we need to understand that authorization is part of a bigger space, IAM, Identity Access Management. So we need authorization to connect to both our authentication and upstream to our identity management, or more correctly, to our customers' identity management. So now I'm going to take you through some best practices on how you can think about solving this problem next time you're building your authorization or access control to your product, or next time you're upgrading your product. If you follow these 5 best practices that I'm going to list, you'll save a lot of pain down the road. You'll essentially be making your product, your cloud native product, future-proof to a significant degree. Nothing is completely future-proof, but it will be significantly future-proof. And that way you'll just save a lot of pain for yourself. So probably the most important best practice that is also becoming kind of a trend, is also being led by the CNCF itself. It's kind of its principles that it's bringing to the cloud native space, is decoupling policy and code. The most kind of naive approach that we have is to bake in access control code or policies into our product. So let's say we have an API or another kind of route in our application. We start handling it, and we just write more code at that point that checks if the user or entity that is approaching that route should be able to use it. And then we have the code for the application itself, the logic for the application, kind of mangled together with the code for the authorization layer. That's a really bad idea, because if once we do that and we start replicating the authorization code between different microservices, when we need to upgrade it, as we saw that we'll probably need, or when we need to add more capabilities to it, or when we need to better monitor it, we won't be able to, because we need to we need to fix a lot of different areas of code, and those will also end up drifting from one another. So we want to decouple our policy from our code. We want to have essentially a microservice for authorization, a separate service where just the logic for authorization will sit there, and the other microservices will use it to achieve their goal of authorization. So that's the first best practice, and probably the most important one. If you take anything from my talk today, please take that best practice. Secondly is being event-driven with how we do authorization. So when you're building an application, things are dynamic within it. People can invite new users on the fly. They can assign new roles on the fly. They can connect or change the things in those third-party services that we mentioned. For example, swiping a credit card. If we have everything managed in a non-real-time fashion, not have it event-driven, we'll have a hard time syncing and getting the data that we need to make authorization decisions. So from the get-go, we should design our authorization layer to be event-driven, meaning every time there's an event that can change authorization, we would want to propagate that through the system to make sure our authorization layer learns about it and is in sync with what's happening in the application and those third-party data services that we might be working with. This is essentially also a way to how we can go and not only decouple policy and code, but also decouple data from code. The data that we need for authorization is not the same data that we need for the application itself. It might overlap, but it's not necessarily the same, and we should focus on having it pair the need for the authorization layer. The third best practice is to be aware of what we end up catering with our authorization layer. So we're not just building authorization to enforce and check what's going on. It's going to be a part of the product. And with companies that are building products, companies that are product focused, in the end of the day, this affects not just the developers, but also the DevOps people and the product managers and security and compliance and a lot of different stakeholders, also sales and marketing. Everyone needs to be able to connect to the access control experience, because as I said before, it's the doorway into your product. So if you can't manage that product, you end up having a bad time. So we want to plan in advance to give controls and interfaces through a back office to the different stakeholders that we have. So we need to, at the get-go, think what kind of interfaces and what different stakeholders would need from the access control to our product. In a similar sense, our fourth best practice talks about our end customers, our end users. So it's not just us managing the product, but also the people working within the product. We want them to be able to have their own audit logs, for example, within their tenant. They should be able to see what they've done within the product. That's something that almost every B2B application user would ask. So we can kind of realize that too late, but if we follow this best practice, we can recognize it in advance and plan for it and build an authorization layer to be able to latch on different interfaces to cater to the different people that end up using the product. In best practice 3, that would be the inside users. In 4, that will be the end users themselves that also need control. And lastly, Gitops. So we've essentially created a separate microservice for managing authorization. We are able to, in an event-driven fashion, deliver updates to it. And so now the best way to kind of go about managing it, applying versions to it, applying additional checks and balances, making sure that the code for that microservice and the data for that microservice complies with our demands and our requirements is Gitops. So we essentially create a pull request for every version change. We connect that to the data pipeline. And then our developers, as they are upgrading the product and its access control, can essentially just push a new commit with new code have that go through the tests and checks, and then have that applied to the overall authorization layer. So these are, as I said before, the best practices, and we need to see how we can combine all of them together to get our product to be as future-proof as possible for authorization. So now that we know what are our goals, essentially, what we want to have in our authorization layer, now let's talk a bit about some open source options and integrations that we can apply to achieve that easily. First of all, before we talk about the solutions themselves, let's talk about the overall ecosystem. So as I said before, authorization is part of the IAM space. And there we want to use open source standards to connect up the funnel. So, and the most important one in this case is JWTs, or JSON Web Tokens. Essentially, JSON documents that are signed cryptographically by the authentication layer. And we can use that to recognize what is the entity we're applying authorization to. And through the authentication layer, through XAML and Open Connector, we can connect to the identity management on the customer side, and through that get additional information about the entity. For example, where they are on the world, which department do they belong to, et cetera, et cetera. So that information will propagate as claims into the authentication layer. And through the JWT, through the JSON Web Token, we can have that propagate into the authorization layer that we're building. It's really important to use those best practices so we'll be able to switch out and use different solutions for both authentication and identity management without having to refactor the entire product. So now we have our identity. We are connected with a user within our code. We have a separate microservice that we're building that will apply authorization based on that identity or based on that JSON Web Token. So now we need a good way to write code for that authorization microservice, have it focused on authorization exclusively, and have it be easily managed by Gitops, as we mentioned before. So there are two main camps today in the market that are bringing engines for building authorization as open source that we can bake into our products. The idea here is that we can obviously go and build a proprietary microservice for authorization, but by using the open source projects, we can save a lot of work, obviously, but also avoid a lot of classic mistakes. There are two camps, as I started to say. The first one is code policy agents. Essentially, a service or agent that can be loaded with dynamic code and have that code then answer queries on authorization. So we have in most cases, a unique language that we can use to write authorization flows. And we have a pre-made service that we can load that language into. We can also load additional data. And then we can ask it things like, does this user have the ability to use this feature? A few leading examples for open source solutions here are Open Policy Agent, which is part of the CNCF, OSO, and Caspin. Open Policy Agent is probably the most important engine in this category at the moment. It also has the biggest community and biggest traction. It's a graduated project as part of the CNCF, meaning it's on par in maturity with Kubernetes. And if you're looking where to start on where you can get your policy agent, that's probably the first place you should look at. The other camp, the other option is permission-based graphs. The kind of mindset leader there is Google Zanzibar. So Google released a white paper on how they do authorization for things like YouTube and Google Drive. In the end of the day, it's basically managing a huge graph that creates a relationship or tracks the relationships for the different entities in your application. The advantages of using that graph is that it can manage a lot of data, and you can have a whole picture, and you can have what's called reverse indexing. You can say, not only does this user have access to this feature, you can also ask the reverse, which users have access to this feature? But on the other hand, it's far more complex. It's much harder to make distributed, and it often comes with network latency because we're managing a separate huge service that is far away from our each microservice that we're managing. On the other end, OPA or other policy agents have the advantage of being very lightweight, having the advantage of being closer to the end microservice that needs their capabilities. So they'll be more performant and there will be less network latency. And it's also, we have more ability to express ourselves because in the end of the day, we're writing code. So it's essentially Turing complete. While with a graph, as if we want to stick to a graph that will be stable to maintain, we can't really go too crazy here. So these have pros and cons, and according to what type of application you're building and what type of access control model you're trying to build, if it's role-based or relationship-based or attribute-based, you'll have different preferences between these solutions. For the rest of the show, I'm going to focus on Open Policy Agent, Opal, and also maybe talk a bit how this can connect to Google Zanzibar and other implementations down the road. If you want to look at the implementations of Google Zanzibar, I've listed a couple here, including Offset and Ori, which are both open source. So let's look slightly deeper at OPA, at Open Policy Agent. So in the end of the day, we have a microservice that is managed by OPA. OPA can be a sidecar to the microservice, or it can run as a separate cluster and be a scaled out microservice on its own. But at the end of the day, we have a service which will be sending queries to OPA to ask it to essentially implement its authorization mechanics. We load both policies in a language called Rego, which you can see an example for here, and data in JSON into OPA. Once OPA has both the data and the policies, we can send queries to it and answer things like, is this user allowed to use this feature? OPA will use a Rego code and check across the data for the user list, for example. The idea with OPA is essentially a glorified memcache. So we load all the data into OPA so it can answer those questions quickly, which connects to what I mentioned before about low network latency and high performance. By separating our code into a specific language and into a specific mindset on authorization, we're decoupling it from the primary application logic, and we achieve the most important principle of decoupling the policy and code. OPA is mostly used today for access control and authorization for Kubernetes, i.e., which microservice is allowed to talk to which microservice. But more and more people are taking OPA into other layers, and we can also take OPA to the application layer. One of the biggest challenges there is keeping OPA up to date, because we need to load data and policies to it, and those policies can change. For example, we create new roles or we create new rules on who can do what, and we want that to propagate as quickly as possible. And obviously the data itself can change. The user list can change. A new user subscribes and joins in, or swipes a credit card and joins in. We want them to be able to get the service immediately and not the next time we deploy. So there's a challenge around keeping OPA up to date with that data that we need to constantly be loading into it. To address that, there's another open source project called Opal, which essentially makes OPA event-driven or real-time. Opal stands for Open Policy Administration Layer because it administrates updates for OPA. You can find it, by the way, at opal.ac and here on GitHub. I'm one of the contributors to this open source project, so I might be slightly biased, but I really think it's the best way to take OPA to the application layer. Opal is server client based. So we have the Opal server, which we can connect our Git repository to. This enables us to be Gitops driven. And it creates a WebSocket pub/sub channel for multiple Opal clients that can subscribe to updates. They subscribe to updates through topics. And every time we push a new policy or load more data, we trigger an event with the Opal server, and it kind of rains down into the multiple Opal clients, which then go fetch the data and load it directly into the OPA agent. So essentially, Opal runs in the background, connects to different data sources and policy sources, and keeps the different open instances that we have up to date. So they will always be able to answer authorization queries correctly when they come from the different services of the application. Next step after that is to kind of wrap everything in a bow, build the interfaces on top. One good tip that I can give you there is to build your code that uses the authorization microservices in a resource-based fashion. Essentially breaking apart your application into different resources and actions, and mapping those into enforcement points, and in those enforcement points, creating links into the authorization layer. So once you map your code into resources and actions, it's really easy to kind of bridge between your classic application logic and your authorization logic in a way that doesn't bundle them back again. Good approach there is often when you're working with something like REST or GraphQL, the routes that you have there are probably already translating very well into resources and actions. You just need to kind of tidy them up a bit. Other challenges that are here that I'm not going to dive into, but I want you to be aware when you're working on our product is, for example, syncing the front end with your the front end experience with your authorization. So up till now, we were mostly talking about the backend. The backend receives a request from the user, decides if to allow it to pass or not using the authorization layer. In the backend, we want to shut the door very dramatically if the user is not allowed to do something. But what about in the front end? We don't want exceptions or errors flying all the time. Even more, we can say if a user is not supposed to be able to complete an action by the authorization layer, maybe we don't want to show them that possibility in advance. If they can't pass through the door, maybe they shouldn't see the door. If they can't delete an object, maybe the delete button shouldn't be there. So there's that challenge. There's another open source project that we'll be releasing soon around Opal that will touch on that. But you can obviously solve it on your own. But the most important thing here is that you should probably be aware of that. And lastly, we want to build different interfaces, as we mentioned before. So we have that authorization layer. We want to build UI components that we can bake both into our back office and into our customer-facing experiences. So we need to think both on how we want to manage our authorization layer. So there are experiences that we want to bake there, and also what we want to enable our end customers to do within kind of a delegated space. As I mentioned before, things like should they be able to view their own audit logs? Should they be able to add users on their own? Should they be able to create roles on their own? Should they be able to create approval flows? For example, someone comes in, they want to approve them dynamically through the application itself. All of these are classic experiences that you've seen in other products, and you are more than likely to see in your own. So planning in advance to be able to build them on top of the authorization layer that we mentioned before can save a lot of pain. Lastly, as we're coming to the end of our time, and I want to leave some room for questions, just a tidbit about what we'll be probably seeing in the future, the kind of hybrid approach. So I mentioned that there are two camps. We have policy agents on one hand, code-based, and we have Google Zanzibar implementation, graph-based on the other side. They both have pros and cons. And those pros and cons are essentially complementary. We can have them work together. So we'll probably be seeing something like a central brain, a graph-based brain that manages the main relationships, and that service would be kind of not distributed. It won't be kind of as a sidecar for each service, but it will be kind of a main one. And we'll have code agents at the edge querying or using data that comes from that central brain. And all of that will be connected with a real-time event-driven link, something like Opal or similar. I hope you enjoyed the talk so far. And if there are any questions, I'd be happy to answer them.
Okay, perfect. So, or if you'd be so kind and stop sharing your screen for a second, please. And I will share mine. Then everybody should see kind of Reddit style options to put the questions to all. So please feel free. Do not be afraid, and raise your questions. And first of all, thank you all for this
My pleasure.
fantastic talk. I learned a little bit something new today. In the meantime, when the question comes in, can you let us know how, if we're talking about the application integration, how, because if I'm remember correctly, that pod security policy from Kubernetes is depreciated. So how you think that will? Do you think that this will bring a new, fresh point of view to OPA and OPL, and will take them to some different direction? What you're expecting? Because you mentioned that the hybrid one, but do you think that this will pay off, for example, in the Kubernetes and and in the application, if we would like to not keep the two systems?
Yeah. So you're asking about the IAM options in AWS?
No, I'm saying that the Kubernetes pod security policy. There's something what allow all the not many people use it. I use it. I love it, but it is depreciated. And one of the things what they were suggesting to move forward, use webhooks and on OPA as a good replacement. And I'm 100% happy with that. But how do you think that this will interact with the future, as you mentioned?
Yeah. So in the end of the day, I think the approach there is kind of rather similar. In the end of the day, you have a kind of language or structure where you define your authorization code and you create enforcement points. In the end of the day, it's just like an alternative to OPA, like OSO is an alternative to OPA. There are, I think, pros and cons. I think the Kubernetes security construct is more focused on the security aspects themselves and not how you are using the application. So in the end of the day, when you're thinking about authorization, it comes in layers. So you have authorization, physical authorization, like who can walk into the building. And you have network level authorization, which IP address can connect to which IP address. And you have zero trust networks, and you have infrastructure level authorization, and then lastly, application level authorization. I think OPA and some of the other options that I mentioned are more relevant to take to the application layer, while the security features are more kind of coupled to the network layer.
All right. So because we are running out of time, there's a fantastic question. I believe that, can you let us know when we can find you on LinkedIn or to Twitter? So
so ORWEIS, both on LinkedIn, Twitter, Facebook, Reddit, everywhere.
So.
And the easiest way to reach me is to go to opal.ac. There's a link to a Slack community. I am there essentially 24 hours every day, and you can ask me questions there.
All right, perfect. So I believe that is a time for our second speaker, Bjorn from Humio. I am excited to hear what you have for us today. So I'm leave the space for you. Can you share your screen, please? And I think it's working fine. You are a little bit muted, so if you be so kind and unmute yourself, we can hear what you want to say.
There we go.
Hey, perfect. All right, I leave stage for you then.
Thank you. So I'm Bjorn Graabek. I'm a sales engineer with CrowdStrike. CrowdStrike, well, actually, let's give a little bit of a history lesson. CrowdStrike acquired Humio beginning of this year after, well, Humio was founded in 2016 and was an independent company for a while. I don't know if people here know much about CrowdStrike, but they were founded a few years before, made an IPO in 2019. They are primarily a company that provides security products. They have their endpoint protection platform is in the Gartner Magic Quadrant as a leader. And as I said, they acquired Humio in February 2021. So yeah, one thing that I thought about putting on here, but I decided not to, but maybe I'll just mention it verbally, is that CrowdStrike has been mentioned in conspiracy theories over in the US. And I'll leave it at that, and then people that are curious can go and find out what that is all about. So, as I said, some architecture. Lots of different security products in the CrowdStrike portfolio. Humio is, I was going to say the latest acquisition. It's not, because there was another one yesterday, but it's a fairly recent one anyway. So why has CrowdStrike acquired Humio? Well, CrowdStrike are going to create an XDR platform, and Humio will be the background, the platform in the background for that. They also want to replace what they are using themselves in the background, and they want to continue to sell Humio as a standalone product. So other than software products, other things that CrowdStrike does is it protects Formula One drivers, as you can see. And very, very recently, we've also branched out into Monopoly games. So what is a presentation without either an iceberg or a pyramid? Well, here's my iceberg, and I call this the data iceberg. And this sort of goes to the heart of what my questions were about. Are people actually logging stuff? And even if they are, is there potentially other things that they could log that would be of relevance? We all lead busy lives at work usually. And time therefore can be a problem, but some of the platforms that may be being used today are also causing organizations to not log everything. It could be for cost reasons, it could be performance reasons, and as I said, it could be time reasons, and then it could just simply be that people haven't really looked into what they could do with the data that is available. So of that data, let me move that window away, of that data that people may be wanting to analyze with a platform such as Humio, much of it resides in data logs, and logs are important. Well, at least they have gained importance. I certainly recall in earlier IT lives where logs was something that I only accessed if an application I was trying to troubleshoot wasn't working. And then I went to the logs to figure out what in the world was going on. Why wasn't it working? And then, of course, the problem was, which server is it I need to log into? Where is the log located? And then to understand the contents of that log. But since starting to work with log aggregation products several years ago, I've come to realize that there is a lot of value. There's a lot of data available, both in logs, but in other types of machine data, because I'd rather talk about machine data than logs. So instead of calling Humio a log aggregation or log management solution, I'd rather talk about it as a machine data platform. And by machine data, I mean data which is time series, which is in motion, and which is quite possibly unstructured. I've shown some examples of what type of data that could be. And I've shown some examples of why you might want to look at these different types of data. Audit and we've just heard about, that could be one, or authentication. Well, auditing that or making sure that you're compliant are reasons why you might want to ingest data about such platforms. So let's look at a simple example of a machine data use case. Most people will probably recognize this as a web server log. And if you look a little bit closer, then you might identify that this is from a web shop. showing something that somebody is trying to purchase. So if we are faced with lots of log entries such as these, then it can be a challenge to find what we're looking for. And we might not even consider all the things that we can find in this data. Some examples are the IP address of the client, which with something like a MaxMind database can tell us approximately where the user is located. And here we can see a product ID. We might even be able to enrich the data that we're ingesting with data from a product database so that we can get a bit more information about what that product is, what it's costing. In this example here, we can see the language setting of the browser. That tells us something about the user who's accessing our web server. We obviously have the time of the request. We have the requested page, so we can get some statistics about what people are mostly viewing on our website, the journey they're taking through our website. There's a status code, which obviously, well, maybe not obviously, but 503, that's not good. That's something that we need to look into. So those are just some brief examples of some of the data that is available within some types of machine data. But the problem with machine data is what kind of data structure do you put this data into? Because all the different types of machine data, it all looks different. And therefore designing a platform which is capable of ingesting any kind of data is a challenge. We have solved that by not using a traditional database. And by not using a traditional database, we don't need users to perform any kind of data normalization to ingest that data and make use of it. But what we can do is we can ingest the data, we can visualize it in its raw form, but we can also make use of commands to create nice and pretty dashboards that actually tell us something, to give us information that is contained in that data. So what I was going to introduce to you is the Humio Community Edition. Humio has been around for a while, as you saw in my history slides. It's a commercial product, and we'd love to sell it to you, but we have, in the last week or so, created a community edition, which is totally free. It's you have ongoing access with no trial period. You can ingest up to 16 gigabytes of data per day. The downside is that you only get 7 days retention of the data that you're ingesting. But who knows? That might be good enough for your particular project. And if not, then it would certainly probably give you enough understanding as to whether Humio is something that could be useful to you. I've obviously included the link where you can sign up. It takes about a day or two before you get access. And as it says at the bottom, you need a Google, Bitbucket, or a GitHub account, and with that, you can request access. So a little bit about the Humio platform. We have a unique index-free technology. Usually we would tell a lot more about what this index-free technology is, but in the interest of time, I'll have to limit myself. What are some benefits of having an index-free technology? Because I mean, saying that we have an index-free technology doesn't really say what we are or what we can. It says something about something that we don't have. Well, it speeds up data ingestion because there is a lot less overhead with ingesting data. And by speeding up the data ingestion, we can have faster search, and we can make that data available right away. And these things become especially important when we are searching for high cardinality data, where indexes probably don't really work anyway, because the data is so disparate anyway. Not desperate, but maybe desperate is too, but disparate. Some other things that come about because of this index-free technology is scalability. We simply need less servers. We need less storage capacity. We compress the data heavily, and since we don't have any indexes, well, we don't need the storage capacity for that. So that has cost implications due to less servers being needed and less storage capacity being needed. And then you will find that if you do speak to our salespeople, then compared to pretty much any other commercial solution out there, our license cost is significantly lower. Deployment choice, self-hosted or Humio Cloud, with the obvious advantages that, or disadvantages that either of those two choices have. So a little bit about data ingestion. Compared to many or maybe most other platforms, we don't actually have our own agent or anything like that with which you can ingest data. And I've just mentioned some examples there of what some types of data might be that you might be interested in ingesting. But we do support a number of APIs. We have our own ingest API. We support the Splunk HTTP event collector API, and we support the Elasticsearch bulk API. So any agents that support those APIs or any method that supports those APIs, we can make use of to ingest data. And here are some examples of what some of those agents or data sources might be that support these different APIs. So a simple syslog example could have you sending data via syslog from various devices to a syslog server, and then using the native rsyslog or syslog-ng modules for using the Elasticsearch bulk API, and then sending the data to Humio in the cloud or on your self-hosted system. Something that might be a bit more interesting for the developers out there is using something like, for example, the Splunk HEC HTTP event collector API, or in fact the Humio ingest API, which looks very similar, where here I've shown an example using the curl command to send data, but that could also be something built into an application where whenever it does something, you want to see that it's been in a particular place in your application, and you can then get it to send data and analyze that. So I'm going to not really do a platform demo because I don't have the time for that, but I will show very briefly what that could look like. And this is where I was told earlier that this is quite daring to actually do something live on air, but let's see if it doesn't work. Here is a command that I created earlier, and by pressing enter there, we should, there we go. There is the data that has appeared in my Humio log system here. And well, as you can see, well, maybe you can't, but I didn't perform any kind of normalization of this data, but Humio has been able to extract keys and values that was in this data. And I could now make use of this data for various analysis. Maybe if I show, actually, that's not what I wanted to do. I want to delete this and show all the data that I am ingesting in this particular system. This happens to be from something called Corelight Home, which is a free version of Corelight software that runs on a Raspberry Pi and which can ingest data directly from that Raspberry Pi to Humio. Let's see, a very simple example of something that we could do is we could want to see something known as the path here. which is the different systems that this core light system is picking up data from. I can click on top, and I have actually for the last 5 minutes live data about what's happening. I could choose to visualize that as a pie chart. Well, it's a donut, but we can turn it into a pie chart. And we could save that as a dashboard widget. And that's really how easy it could be to analyze your data. I could also create alerts so that you don't have to sit glued to a screen to monitor what's going on. But the particular kind of query that I executed here is not the kind that I would use for that. So that was this is using Cloud Community, the community version of our cloud service. This, as you can see here, are some of the license limits that you also saw on the earlier slide. As many other packages that could do this type of thing, we have the ability to install packages from a marketplace, and here are some of the examples of the things that you can install out of the box to analyze data. And of course, you have the ability to create your own packages for Humio. That's probably all I have time for in this, as I said, short platform demo. So what my key takeaways are, and I realize I didn't have quite a huge amount of time to really go into any great depth about this, is you should log everything. And what makes Humio unique here is that it is a platform that, through its architecture and its costs, actually makes it possible to log everything. And although things like observability are considered the new cool kid, you really need to combine that with logging, and Humio is the platform that will give you speed, scale, and lower cost. And then just again, the URL for signing up to get a free version of Humio in the cloud. Thank you.
Okay, perfect. I believe we have solid 5 minutes. So if you would like to, you can go back and to the demo and show us more, because it's very interesting.
Okay.
In terms of the, for example, creating alarms. It is one of the things what I'm testing all the platforms. I found it very sometimes challenging because it is not exactly intuitive. So if you maybe this is will be good things to show us, please.
Okay. I'm trying to think what could be a good example. Actually, if I quickly load up another, go into another system, then I have some more relevant data that I could use for this. About that. Okay, actually talking about log everything. This particular place here is actually data that I've been ingesting from an Apple Watch. So again, it goes, it proves the point. You can log everything with Humio.
Oh, that's interesting. That really is. I never seen that you can log something from the Apple Watch.
There is an app which uses the HEC API and sends data. So I can see where I am, how many steps I've done, and see how many calories I've burned, probably not enough, and heart rates, which doesn't seem to be in this particular step right now. But what I really wanted to show as an example is here where we have some AWS data. And I could see a few reject messages here. And if I look here and say action, well, I want that to be equal to reject. And what can we see? We can see that I've had 40,000 rejected entries in this log. Now, maybe that's normal, maybe it's not, but simply doing something as simple as this and then saying I want to create an alert, and I want this alert to kick off if I have more than a certain, let's say, a certain number of reject messages, then I want to be alerted. And how do I want to be alerted? Well, maybe I want to be sent a Slack message. Well, these are just some of the things that are built in here. You could do webhooks. You could do all sorts of things really here. So that's really it. It's the same kind of queries that you would use to search for data that you would use to just create an alert. Once you create an alert that shows you the data that you want, once you create a query that shows what you want, then you could set that up as an alert.
All right, perfect. If you stop sharing your screen, I will share mine, and there is a few things what I would like you to see. This is the questions for Bjorn. I will already have two, maybe not the questions, but praises basically for Humio. First one, great presentations. Thanks for your time. It's always nice to hear. And the second one, we are looking for something similar for JSONing standard Go logs. We're using temporary Docker containers and ingestion testing multiple microservices. This will be blended to the various formats depending on the Swagger server application layer doing the logging. We'll take a look.
Excellent.
So, that's fantastic in my opinion. You managed to find the people what they really will give a shot for Humio, and I'm happy that that we have find some solution for someone problem.
Excellent.
Do we have 3 more minutes? Maybe someone else have a question. Maybe something else. In terms of, so in the meantime, maybe I will ask, you mentioned that because what is really I want to ask is just like if I want to use the log aggregation system, right? And I will be looking, there is a few options and Humio is one of them. What do you think will be the something what will definitely take you apart from all the competitors? We have a cloud providers where they have their own logging solutions and stuff like this. Sometimes, so what if I would like to convince my CTO to the Humio? What argument, the biggest argument what I can use to make this thing going?
So, I mean, you mentioned the cloud providers. Now, if every single service you have is in the cloud and with a particular cloud provider, then you in theory you possibly don't need anything else. Although the analytics options are usually quite limited in those platforms, and if your data is not all from that particular cloud provider, it's from other systems as well, then you do need something else. Now, as you said yourself, that's something else. There are other products than Humio on the market. What does set us apart is that we need, as I said, a lot less hardware, and that we are faster. I don't know if you noticed on the search bar, the developers have actually put an entry in for how many events we've searched per second, because they were so proud about the amount of data that our engine can search through in very little time. So yeah, speed, scalability, and cost is what's up.
All right, perfect. Thank you very much for that. I believe there is no more question for you, Bjorn. So tell us how we can find you, please.
Well, I do have a Twitter profile, Graabek. I didn't include it in the beginning because I tend to mostly tweet about when I get upset about something in politics.
We all do that. We all do that.
And also, it's fairly recently that I joined CrowdStrike. I was previously with one of the competitive products. So most of the tweets so far have been how great the other product that I used to work with is.
That's interesting. That's interesting. Okay. Thank you very much for that. Thank you very much for your time. Thank you for the presentation. We'll take a 15 minutes break. So please do not go anywhere. Take it, maybe go to grab something to drink then, and we'll be back
And
for Seth.
Cloud community version in that break.
You can give our shout to the community version if you would like to. So if you want to sign up to Humio, please. But next is a Seth with his stateful functions. I'm excited. And yes, I believe that we will be back in 15 minutes. So see you there. And welcome after the break. Welcome after the break. We are hopefully everybody is refreshed and ready because in front of us, Seth, and we'll be talking about the stateful functions. Again, I never heard about this, and I'm keen to hear more. So if you be so kind and
Great.
start sharing your screen, and and I'll give a spotlight to you.
Awesome. Thank you all for having me. I'm excited to be here. My name's Seth. I am a solutions architect with Ververica and committer on Apache Flink. And today I want to talk about application development, microservice versus monolithic architectures, the trade-offs between the two, and then introduce you to stateful functions, which is looking to bring a different set of trade-offs tailored towards the cloud native world. So I thought the best way to do this would be to start at the beginning, see how these different paradigms developed. And of course, the world initially did its computing on mainframes where the single big machine is going to handle everything. And so the way these things work is, you read some data from tape, you do some computing, and then you write those results back out. And obviously, we've moved away from mainframes for a lot of reasons, but they have this really interesting quality of being simple to reason about, right? Things are more or less atomic. The process either runs to completion or not. But of course, the world moves on and we get to two-tiered architectures, or what I'm going to broadly classify as a monolith today. Compute and storage are running separate processes that can be deployed and updated independently. But it's still very easy to reason about failure domains. Either the system is working or not. The problem with this model is that it requires heavy coordination between teams. Everyone needs to be using the same language and library versions. We have coordinated deployments, and the system really scales all or nothing. And so recent years has seen the world move towards a microservice-oriented architecture, what I'm showing in this diagram. Organizations are deploying business logic via stateless tiers, and so that allows for simple deployments, dynamic rescaling of services. State management is then coming via some other tier, database, data store. Details aren't so important. And this architecture has a lot of really attractive qualities. Teams can deploy their services independently and use different components and have different components be implemented using the most appropriate tool. What has enabled this shift is what I want to refer to as modern infrastructure, comprised of 4 tenets. Rapid scalability of our applications and the ability to scale to zero, meaning we do not pay for idle time. Fast, zero downtime upgrades, and generally more straightforward operations for our applications. It is now often easier to deploy another service to production than coordinate effort between teams. And so if we're running a service that operated entirely independently and was stateless, there are a lot of really great tools for us to use here. Fully managed services like AWS Lambda or Azure Functions. Maybe we do it ourselves using something like Knative. And if we have maybe a more complex scenario, we could reach for something like a Kubernetes deployment. Where this model becomes complicated is when we need to consider stateful applications or orchestrated communication between components. I'm going to define a stateful application as anything that needs to remember information beyond the scope of a single event. And so usually a request is going to come into the system and the application might go to the database or retrieve some information that we'll use to compute a value. Maybe we talk to another service and it'll do the same, reading and updating some values in its data store before responding back to the first and finally sending a result off to the client. This is a really great model if everything goes well, but it becomes very difficult to reason about consistency under failure. If application 2 does not respond, for whatever reason, application 1 doesn't know what happened and how it should handle that failure. Did the request or response fail? Did something go wrong in our code? Was the database updated? Do we need to perform a rollback? Is it safe to attempt a retry? Is everything running fine and the network's just a bit slow today? All these scenarios need to be accounted for and handled by our application. And so here's an example of this architecture implemented on AWS. So events are coming in and out using Kinesis streams. Our user code is deployed via Lambda functions, and DynamoDB serves as our data store. The problems I was just describing are going to apply here as well. In general, it is going to be very difficult to have any sort of global consistency or have any sort of global guarantees about our system. If we're in a serverless context, there are a few additional problems we do need to think about. So if we were to implement communication across components like this, we would be paying for wait time. And so while Lambda function 1 calls Lambda function 2, both these things are running and we are paying twice. Similarly, there's a lot of wait time for DynamoDB as we read from and write to that data store. And so what you usually do is put some queues in between these components. And now functions are asynchronous, only one's running at a time. Maybe we do something similar on DynamoDB side, have a bit of a caching layer, but our architecture is getting more complicated. There are more components that need to be monitored and, importantly, paid for. And the consistency question becomes even more difficult. Now, for our user code, these Lambda functions are going to scale quite unlimitedly. But connections IO to the database, and the database itself may not. Application code needs to consider potential limits. So let's suppose that a large influx of messages comes into the system, and the number of running Lambda functions suddenly spikes up to support that load. While this might appear to be the right solution on the surface, it's going to cause headaches if we scale beyond the number of concurrent connections our data store can support. User code is now liable to get request rejected exceptions that need to be dealt with appropriately. The scenario means we are paying for wasted resources and making our user code more complicated. And so the question is, does it have to be this way? And what I hope to show you today is that no, it does not. So Stateful Functions was built specifically to solve this problem. It is an open source project and is a cross-platform stack for building stateful applications, making it radically simpler to develop scalable, consistent, and elastic applications on modern infrastructure. Now, the way that we go about this is by reconsidering the fundamental question of which component handles the messaging. Why should user code call into the database at all? So instead, we have inverted this problem and have the database handle the messaging for us. So this time, the incoming message is going to go directly to the database, and the database is going to call into our application code. It'll send a request containing the original message, as well as all state that is required to process that message. The application may then respond with state updates to apply to the database, along with messages it wants to send to other applications or functions. And then another application is invoked. Again, state is sent to the application along with the message and responds back with state updates and again, more messages to send along. And finally, just as before, we can send a final result off to the client. The critical insight here is that the database handles the messaging. So whenever a message is lost or connection times out, the database knows and can consistently roll back state and messaging atomically. All calls to application code are automatically made idempotent. So user code doesn't need to consider retries or duplicates. From an application perspective, everything happens exactly once. Another advantage of this model is that we never need to pay for wait time. Everything is automatically asynchronous. We only invoke application code when there's actually something to do, and it never needs to wait for reads or writes to the data store. Last but not least, we are never going to outscale our resource constraints. The database is the more difficult to scale component, but it can now apply sophisticated back pressure mechanisms to messaging as it reaches its limits. So if we go back to our AWS example, we can see how stateful functions makes things simpler. Kinesis stream still gets messages into and out of the system. Lambda functions are still running our user code. But this time, the stateful functions runtime will perform state and message handling consistently and correctly. Now, you might be looking at this diagram and saying, did we really make it simpler, or were you just swapping out one component for another? Well, I would begin by saying we are solving for a whole class of problems, right? State, messaging, consistency is now solved for by this runtime. That said, we still do want to be good citizens of the cloud native world, and that is why the runtime is also stateless. It will maintain local caches for performant reads and writes, but does not rely on being recoverable during failure. There's no need for persisted volumes, stateful sets, or other complex infrastructure components. Instead, durability comes via asynchronous state snapshots to an object store. So that durability that DynamoDB previously handled now comes via S3, which is cheap, scalable, and reliable. So what stateful functions is looking to do is provide all the advantages of modern infrastructure: rapid scalability, scale to zero, all these good things, because our compute tier is still stateless. But by combining messaging and state in stateful functions, we get consistent, durable state based on cloud native fault tolerance. And we have robust, easy to use messaging primitives between components. All communication is going to occur through message passing, and functions can message each other based on logical addresses, even with strong ordering guarantees. So no need for service discovery or queues. And this whole thing is implemented on top of the Apache Flink runtime, which has been proven out at scale in production for many years. So we are able to leverage its distributed coordination, ability to handle multi-terabyte state, highly optimized networking stack, and many other goodies that we get for free. So that's the basic idea of stateful functions. I want to now talk about some of the concepts, right? What does it look like to use this thing? So users develop applications by implementing several services, or what we very creatively call stateful functions. They're basically small bits of code or logic representing entities within an application. So we can write stateful application logic in any language. The project ships with Java, Python, Golang, and TypeScript SDKs. But you can use any language you like by implementing our protocol. And because the runtime is language agnostic, functions can communicate seamlessly cross-language without any ceremony. And now all this communication does occur through message passing, and function invocation only occurs when there is actually a message to process. So our user code will never consume resources unless actively doing something. The runtime will, in the background, set appropriate context, such as state and other metadata, for each message. And this means that we can model our entities in a very fine-grained manner without exploding our hardware resource constraints. So we could, for example, define a function representing a customer with a single logical entity modeling every single customer of our application. The number of logical entities may grow indefinitely as we sign up new users, while the number of physical instances only needs to grow or shrink based on active throughput requirements. Next is dynamic messaging with consistent state. What this means is that we do not need to predefine any communication patterns, just as you expect with any general purpose programming system. Any function can message any other arbitrarily by sending a message to its logical address. And because these are logical addresses, there's no service discovery. All message passing is fire and forget. And we can do this with what we call exactly once state semantics. So functions are going to have access to what we call address scoped state, and the runtime will integrate messaging and state updates for out-of-the-box consistency across event inputs, application state, and outputs delivered from the application. So we can take a look at a really simple bit of stateful user code. This is our greeter example. It's sort of our hello world, but with a twist. So for every user of our system, we are going to be calculating a custom greeting based on the number of times we've seen that particular user so far. So it might say, hi, Seth, welcome back, Seth, third time's the charm, Seth, each time I get a message. But if John is also getting messages, he will see his count be updated completely independently. So in this case, I'm using the Python SDK. And as you can see, I simply import the Python SDK and have this decorator associated with my Python function that implements the logic. A stateful function in Python will be anything that takes in two parameters: a context, the thing that gives us access to our runtime capabilities like state and messaging, and the actual message under invocation. Now, these type names that you see here, com example fun/greeter and com example fun/inbox, are those logical type names. So when someone wants to send a message to the greeter, they don't have to know that it's Python code or where it's running or anything about it. They simply need to know this logical type name. Similarly, we are going to be sending our greetings to a user's inbox. I don't know where that code is running. I don't know what language it's implemented in. It doesn't matter. The runtime is going to handle all of that for us. And within our function, we have access again to this address scoped state. So think of these as durable variables that are guaranteed to be consistent across function invocations. So in this example, I've defined a single variable called scene count that is an integer. And from my storage, I can access that and use it like any other Python variable. So I don't need to do anything special here. I simply access the count. I can read it, I can write it, I can update it, I can do all sorts of things with it. I can treat this like regular old Python code. But in a failure scenario, we will guarantee the consistency of this value. So as you're seeing the output of this application, You will never see dropped or duplicated messages, even if something fails and has to restart. And finally, we can send messages to other functions. So I am sending my greeting to a particular user's inbox, but again, I don't care where it's running. I don't care what language this is implemented in. And finally, the way that the runtime interacts with user code allows us to seamlessly take advantage of these modern deployment tools like AWS Lambda or Kubernetes services, retaining their operational management benefits. So when a message targets an address, it is first routed to the database shard, storing that message's state within the runtime. Only then is a message and its state value sent to user code as a single atomic payload. The response will contain new messages to send to other functions, and any state updates will apply to the data store. Because this protocol encodes all information in a single payload, the invocation is trivially idempotent, allowing for simple retries. And the runtime is going to handle all the asynchrony for us, invoking multiple independent functions at once for scalability, while knowing which ones require strict ordering to remain consistent. We have a model here where compute and state are logically co-located for consistency, but at the same time, physically separated. We can deploy independently and scale different components written using any language on Stateful, giving us the operational benefits of a microservice with the consistency of a monolith. Now, what's really important here is that we do not have any opinion on how your user code is deployed. Instead, we want to integrate with your existing tooling. And each SDK is going to come with what we call a request reply handler. This handler is responsible for implementing the protocol and does so in a framework agnostic way. It does not perform any network IO and is embedded easily into your deployment framework of choice. So for example, we might use the Python SDK to deploy our function using AWS Lambda, but could also deploy it using a standard server framework such as AIO, HTTP, or Flask. With the Java SDK, we might choose something like Undertow or even Spring Boot. And the Golang SDK simply implements the standard Go HTTP handler interface to be easily embedded into any standard Go web framework. All these SDKs use a standardized type system, so functions written in different languages can communicate seamlessly. So with all that being said, what can you do with this thing? It is meant to be a general purpose application framework, and so you can do lots. But one really interesting use case is model serving. So the last decade has seen companies heavily invest in machine learning. Teams of data scientists can build models solving complex problems that were out of reach just years ago. But unfortunately, this is only one part of the problem. The real value in machine learning comes when successfully deploying models to production. Unfortunately, according to industry reports, only 22% of organizations using machine learning has successfully deployed at least one model to production. And out of that cohort, over half believe deploying another would take at least 90 days. Why is this so difficult? What requirements do we need for a proper model serving infrastructure? Well, first of all, we need to be able to continuously deploy the actual model without downtime as the team refines it. The deployment should be rapidly scalable, Models may require expensive hardware, and so it's crucial we can rescale with traffic, never paying for unused resources. But beyond the model itself, we have a lot of components that sit around it. Data points need to be processed, cleaned, and stored for feature vectors. Users may have different configurations specifying how the system should interpret model scores. And of course, a component to act on that model's output. Teams other than data science may develop these components using their own programming language and libraries and be on independent deployment schedules. Well, these are exactly the sorts of problems that Stateful Functions was designed to solve. In fact, I'm so confident we can solve them, I am thrilled to announce we have successfully funded our next startup, Fraud Alert Inc. And we are all coming on board to bootstrap our ML ops team. So what we're going to do is take the highly sophisticated model our data scientists have developed and get it into production. Our goal is to process credit card transactions and alert customers if we believe a transaction to be fraudulent. So this diagram shows a high-level overview of the application we're going to be walking through. There's a transaction manager in the middle, or think of this as our coordinator, and it's going to build up a feature vector across several different dimensions, a fraud count and merchant score. Once it builds up that feature vector, it is going to send it off to the model for scoring. If the model responds with a value above some threshold, then we'll send an alert to the customer saying, we believe there to be fraudulent activity. All of this is going to be done with consistent state, independent deployments, and support for rapid scalability. So I have gone ahead and implemented this thing, and we're going to step through a little bit of the code just to give you a taste of what this looks like. So the first component is our transaction coordinator. This is the thing that sits in the middle and pulls everything together. So these value specs in our Java SDK, because I am implementing this in Java and it's going to be deployed as part of a Spring Boot application. We have 3 value specs: the transaction, the fraud count, and the merchant score. And these are things that are going to be stored in our address scope state. So they are durable and consistent. When a transaction comes in, so when a message comes in that is a transaction, then what am I going to do? I'm going to store this transaction as state. I'm going to put it into my storage so I can remember it later. And then I'm going to send off some messages, one to the fraud counter function and one to the merchant score function, asking them, hey, I'd like to query the current value. When they respond back, we are going to store things into our storage as we wait for all the different feature vectors to respond. But when they do, we'll send a message to our model. Hey, go ahead and score this feature vector for me. At the very end, when the model returns back a value, we'll say if it is above some threshold, then go ahead and send an alert. In this case, we're going to be writing out a value to a Kafka topic. So my fraud counter, one of our functions, is also implemented in Java and part of that same Spring Boot application. So it internally is going to be maintaining a single variable, which is a counter. We're keeping track of the number of times this particular account has flagged fraudulent activity over the past 30 days. And so if a confirmation comes in, then we are going to update our counter, right? We're going to read that value and then write it and update it. And we're also going to send ourselves a message that won't arrive for 30 days to decrement that value so we can maintain this rolling 30-day count. If we get a query message, so the thing we sent from our transaction coordinator, then we're going to just read the current value and send it back to the caller. And finally, we have a little bit of logic to go and decrement our counter when it expires after 30 days. Now, for the merchant score function, we're going to be talking to a third-party API. Think of this as a trustworthiness score, right? How likely is it that there's fraud coming from a particular merchant? And so I have a REST API that we're able to hit from our third-party provider. And I thought, you know what? Golang has really great HTTP clients. I want to go ahead and write this function in Golang. So we have our merchant score, and we've defined this as a stateful function. Now it looks a bit different because it's Golang code, but it should seem very familiar. We have a context and we have the message. And with it, we can read and write values and we can send messages to other functions. So if a message comes in that is a query, so that thing we sent from our Java code, then we will check our address scope storage to see, do I already have a score for this merchant? If not, I'll go use my client to hit that third-party API and then write it into my address scope storage. This gives me a sort of cache so that I'm not hitting that API a million times if I have very popular merchants. And finally, again, we can send a result back to the caller, that Java transaction coordinator. All the type systems is going to be handled for us, and so I don't need to worry about what language that caller was in. I'll simply send them the integer and it's going to work. And finally, we have our model. And of course, for model, it's probably going to be Python code because we want to use our great Python libraries. And so when something comes in that is a feature vector, we're going to go ahead and run our complex model. I'm not a data scientist. In this case, it's simply a random number generator, but you can imagine this could be something like TensorFlow or something built up with NumPy or SciPy, whatever library you like, because this is real Python code. And so all those tools are available for us. And we'll calculate the score and again, forward it along, not worrying about who is actually processing it or where that processing occurs. We know that this will arrive statefully and correctly and consistently. So I do, in fact, have this thing up and running. There's a lot of logging going on to show us what's going on in the background, and I want to just show a little bit of it. So you can see we are scoring different transactions. If it is above some threshold, we're sending alerts. We're sending things to our different functions. In this case, we can see we were looking for a score for a merchant and it wasn't already in our address scope storage. So we're actually hitting the client in this case. All sorts of good stuff going on. And if I wanted to go in, I could make a change to my user code without any downtime. I could start failing different components of my runtime, and everything would remain consistent. We would never double process. We would never drop any messages. It would be as if everything happened exactly once. And so that is a whirlwind tour of stateful functions. Again, we are a platform for building stateful applications on modern infrastructure, giving you the benefits of a microservice-oriented architecture with the consistency of a monolithic application. I would love to take any questions, and I thank you so much for having me today.
All righty. So thank you very much, Seth, for this presentation. I have a question. So if you please stop sharing the screen, I will share mine and we will get to the question. So you should see the question, but I will try to read it. What is the experience with the big state and needed network throughput and resulting performance with the state fun? Flink can handle small state really fast in heap or still fast, RocksDB. But in the state fun, state is all the time second round. What is the complex data types needing to costly for SREDE?
So let me, for those of you that have not used Apache Flink in the past, so Stateful Functions is a framework built on top of Apache Flink, and which has a lot of really powerful capabilities for state management. With StateFun, we are always, the processing in the actual Flink cluster actually happens asynchronously to your user code. And so a lot of those trade-offs between what we call the hash map state backend and the RocksDB state backend simply do not apply here. We are always going to use RocksDB because in this model, we want the scalability. And we also want to be off the JVM heap because that gives us a bit more reliability within our system. As far as state being sent around, yes, that is true, but we are only sending exactly the state you need to process the given message. And so it tends to, in practice, just not be a problem. As I mentioned, we have our own type system. So we have all the built-ins or primitives that you would expect, right? Ints, floats, doubles, strings, all those good things. But we do have the ability to plug in your own types for more complex systems. From the runtime perspective, though, everything is bytes. And so you can use any sort of Saturday you like. We are completely hands-off. We want you to use what you are comfortable with. Is there also no downtime when the logical processing graph changes? So again, I assume this person is talking about the StateFun runtime. So StateFun is very different than any other Apache Flink application in that user code runs independently. So user code can be deployed, updated, scaled completely independently and with zero downtime. The runtime does have a data flow graph in the background, but it is actually static. So there is downtime when you want to make changes to the runtime, but you rarely ever have to make changes to the runtime unless you are, say, upgrading to the new version. It is a static backend. And so just like you can make changes to tables in Postgres without taking Postgres offline, you can make changes to your StateFun application without taking the StateFun runtime offline.
And at the end, thank you, Seth, for the presentation. You know,
thank you for joining.
That's amazing. Thank you very much. So the last thing, because we are warming up, it's 9 o'clock in the UK. If you would like to join us, we will be probably handling on the Rambly. It's on the, if you would like to join and have for the little bit after party, there is a oicheryl.com/r, and we would like to welcome you there. And at the end, if you would like to be talking, if you would like to be sponsor, hit me out, hit out our app. This is the link, please. We have a free spots for speaking, and I will see. We will meet again this year on the 1st of December, 2021, on the here on virtual meeting on the YouTube, on the Twitter, on the YouTube, on the Twitch, and if you stay with us till now, hit the like, subscribe if you want to more, leave a comment what you would like to see more, and yeah, and I will see you there. Thank you very much for everybody for joining today, and I will see you around next time. Bye.